came and said, "You did not recognize us." So I would like to acknowledge the Basotho people from the Kingdom of the Mountains. A round of applause for them, please. Ladies and gentlemen, welcome again on day 2 of this auspicious occasion. Just to remind you, after enjoying the South African wine last night, that we are in the UNESCO 9th Africa Week and the 7th Engineering Week. Yesterday, the VP started us off and urged us to celebrate and grow this engineering profession with excellence in the African region. And we're going to go along in that mode. Before I go any further, I would like to honor our special guests and leaders who've joined us today. Firstly, to acknowledge the presence of the Honorable Minister in the Presidency for Electricity South Africa, Dr. Hosi Entu Ramuhopa. A round of applause for him, please. I must mention, last night I was telling someone that he's one of the few engineers who have the guts to go into politics, so we're going to learn a lot from him today. We have our high-level delegates from various areas on the continent, starting off with the Deputy Governor of Ogun State, Nigeria, Her Excellency, Engineer Salako. We have the Head of Education, UNESCO, Mr. Peter Wells. Welcome, sir. We also have the President-elect of the World Federation of Engineering Organizations, President-elect Engineer Mustafa Shehu. We have the President of the Federation of African Engineering Organizations, Engineer Papias Kazawadi. Next, we have the Deputy Chief Secretary in the Office of the President, Zimbabwe, Engineer Amos Marwara. We also have the Chair of the International Engineering Alliance Governing Group, Professor Elizabeth Taylor. To acknowledge our hosts, starting off with the President of the Engineering Council of South Africa, Engineer Rifilwe Buthelezi. Next, we have the Vice President of the Engineering Council of South Africa and the Council member as well, Engineer TC Madikane. Next, we have the Chief Executive Officer of the Engineering Council of South Africa, Dr. Bridget Samula. I would also want to acknowledge the Chair of Africa Engineering Week. We had him on stage yesterday, Engineer Martin Manua. And also acknowledge all African Union delegates as well as ADIA. All protocol observed. Moving on to the next item, would like to call up to the stage our host, Dr. Sandile Malinga from the CSIR, to give us some opening remarks. A round of applause for Dr. Sandile Malinga.
How are you doing? How do I? Is this? Yeah.
Can we have the media team putting up his presentation, please?
Okay, Minister Ramokgopa, thank you very much. The distinguished guests, I would like to thank the MC who has assisted me by acknowledging everyone who's here, and I feel honored to be amongst engineers. So I'm a physicist, and I feel outnumbered. And I'll tell you a story about when I was lecturing at the University of Natal, Durban, at the time. Every time I taught engineering first-year students, they, whether it's a spring constant, how to derive a spring constant, they just say, give us the answer, we want to use it. When we don't care about how to derive it. So I feel outnumbered today to be amongst the engineers, but I'm delighted to be here. I'm going to present about the CSRR, what we do. Sorry. The CSR is an entity of the state that was established to conduct directed research, as well as to support our nation in terms of industry and science, knowledge, and to solve problems that are there within our country. We've been in existence for about 78 years, and so we're approaching our 80th anniversary in about 2 years' time. And our vision as the CSR is to be accelerators of socio-economic development and prosperity in South Africa through innovation. And so we pride ourselves by being innovative, and we work very, very closely with engineers, and we do this collaboratively. We believe that for us to be able to conduct the research, innovation, and technology that's required, we have to collaborate with a number of people. Our values are about excellence, being people-centered, integrity, and to collaborate. And this translates to an acronym, EPIC, which is what we strive to be as the CSR, to be an EPIC institution. We have a strategic intent as an organization, which is to grow South Africa as well as to grow the CSR, to be sustainable as we do so, and to ensure that we have impact and we have relevance in what we do as an organization. In terms of, at a glance, the CSR consists of about 2,200 employees. About more than half of those are South African, Black South Africans, and we pride ourselves by having a large contingent of female South Africans as well. The work that we do requires that we have experts in terms of scientists as well as engineers, and the larger population of the staff within the CSR are what we call science, engineering, and technology staff members, and that constitute more than half of the employees within the CSR, and the bulk of those are South Africans. Qualifications are very important within the CSR. We have a total of about 317 PhD employees. About 400 of those have got masters. And then the thing that we still have to improve on is EXA registered engineers. At the moment, we have about 32, and we want to work with EXA to ensure that we increase that number. We pride ourselves in employing employees with disabilities, and issues of governance are important, and we've obtained about 13 years of continuous clean audits as an entity of state. Our outputs are varied. We have publications, we have priority patents, as well as technology demonstrators and license agreements working with industry. And technology localization is very important to us and working with industry. This just gives you a sense of the things that we produce as the CSR. In terms of our delivery platform, the CSR consists of 9 clusters, and these are divided into 3 divisions. Along 2 of these divisions are industry-facing, which is the Advanced Chemistry and Life Sciences division, and I'll talk more about what it does. And then the other industry-facing division is Advanced Manufacturing and Security, And then lastly, there's a public and industry-facing division, which looks at both the public as well as industry. And I'll elaborate more on what each of these does. Starting with advanced chemistry and life sciences, they have 3 clusters, and these clusters look at agriculture. And under agriculture, there are 2 areas of specialization. The first one being agro-processing, to look at how we efficiently process our produce, as well as food safety and being competitive as a country. The other area that they focus on is precision agriculture, to use for IR and other technologies for better farming, from GIS using space technologies for information and precision agriculture. And then there's future production of chemicals. Here we're looking at green ways of producing chemicals. From hydrogen, green hydrogen is an area of specialization within the CSR, especially as we move towards green energy and renewable energy. They also specialize in other products in chemistry, looking at better ways of producing pharmaceuticals. During COVID, you would have realized that as a country, we're challenged in terms of vaccines. And the DSI is committed to ensuring that that is addressed, and part of the work that's being done under our chemical cluster is to come up with pharmaceuticals that will empower our country. And then there's next generation health. Here we're looking at 4R technologies for health, with particular emphasis on point of care diagnostic for both communicable and non-communicable diseases. And we do quite a number of innovative things here, looking at how can one come up with genetically superior ways, as you are well aware that drug resistance as well as adverse reaction to drugs due to genetics is prevalent in our country and in the continent, where most of the sort of pharmaceuticals that are developed are not tested on people of African genetics, which then leads to a number of adverse effects. And so the work that we do here looks at those kind of things. How can we use genetics to inform any medication that's being developed, and so that we are not adversely affected by it. And then the second division is that of advanced manufacturing and security. Under this one, we look at issues of mining. As a country, we are a strong mining country, but the technology that's required as our mines become deep and unsafe need to be more sophisticated than otherwise we've been exposed to in the past. And so as the CSR, we develop new technologies, 4R technologies, to improve our mining, as well as energy. We've just been working with some of our mines in our country on installing hydrogen systems for their transportation in the mines. The second area is that of manufacturing, and again, using smart technologies for manufacturing. As you are well aware, our country has lost its standing in terms of manufacturing, whether it's textile, electrochemicals, and so on and so forth. And as the CSR, we're using robotics, automation, and other new technologies to ensure that we recapture the standing that we used to have as a country. And then lastly, under this division is defense and security. Here, developing sophisticated technologies of radar, surveillance, optronics, and many other applications for our own defense as well as for the export market. And then the third division is that of smart society. And under this division, there are 3 areas of specialization: smart mobility, looking at materials that we use for our roads, our bridges, and making those resilient to changes in climate change, as an example, as well as operations, looking at sophisticated and more efficient transportation systems under smart mobility. And then we move on to smart places. Here we do a number of things, looking at climate change, ecosystem sustainability. This is where we have our energy center that focuses on grid modeling, grid optimization, as well as we've just launched a microgrid center of excellence recently. And we also have a battery development technology looking at cathodes and anodes within the CSR, as well as we recently launched a battery test bed together with the Belgians, as we will be, as a country, experiencing an influx of batteries coming into the country, and testing those for good quality and durability is the work that we do together with the PV lab that we have within the CSR. We also have a water center within this cluster that's looking at renewable ways of sustaining our water systems and purification of water, as well as supporting the Department of Water and Sanitation. Lastly, we have a next generation enterprises and institutions, which looks at technologies in a 4IR, data analytics, as well as machine learning and all those technologies. We work very closely with the Department of Health in terms of modernizing and automating our health system, as well as working with other government departments like Home Affairs. How do we do our work? Just taking you through the different divisions that we have within the CSR. But in the main, we provide different solutions as the CSR. Technology development is what we do. An example that's given there is the radar systems that we provide. We also develop products of different types, from flavors and fragrances, biocides and cosmetic products developed within the CSR, working with SMEs within our country. We also develop custom solutions of varying type. An example that's given here is the work that we do develop a surveillance system for the National Kruger to curb rhino poaching, and this system has worked very, very well. And we do other custom developed solutions for different clients that we work with. Before I do that, and then evidence-based decision support, we do, as I indicated, we have a lot of data that we use. We work with our clients using sophisticated simulations, data analytics, and provide decision support tools. Some of those include the Green Book that municipalities are used in terms of mitigating climate change impacts, as well as the Red Book that talks to how buildings can be designed to be more resilient in the new world that we live in. We also have a number of test facilities that are provided, whether it's the wind tunnel that we use for defense and other applications or aerodynamic testing. We also have in the Western Cape a port modeling that is used for the design of ports. I spoke about the PV lab that tests solar panels in terms of quality and durability. Test battery lab as well that we have within the CSR for testing batteries. We host a number of programs for different entities, the TTCI, we host for them the National Clean Production Center that looks at how we can more efficiently run our industries in terms of temperature, the use of the heat that's being excreted back into the system to secularize the operations within industries, as other eco-techo methodologies that are applied through the National Clean Production Center. There's also, we also incubate a number of facilities within the CSR. We have a biomanufacturing industry development center that incubates a number of SMMEs for biomanufacturing. We have others, biorefinery as well, where SMMEs and small researchers and industries can be incubated as they develop and mature in their craft. Technology licensing is very important to the CSR, and so we have a wealth of IP that we own. And this is available to any industry that's interested. You can go to our website and look at some of the industry that are available to be licensed if you're interested in that. We also offer specialized training. We have a learning factory that teaches, and when we talk of just transition, how can you equip people for new technologies? As AI comes in, people are being displaced in the work that they do, and it's very important that they are reskilled so that they can be still gainfully employed. And the CSR offers training to upskill people in different areas, in robotics, machine learning, and other areas, working with our cities in our country. There are also highly specialized work that we do. We've just recently been working with ESCOM on, they have turbine blades that when they get damaged, to replace them is very, very costly. So using laser technology, we're able to work with ESCOM to repair those blades so that they can be used for our country. And then lastly, is just to give you a sense of our collaboration on the continent as well as globally. The largest number of collaborating institutions that we have is on the African continent. As you can see, about 65 of the institutions that we collaborated with are on the African continent. The area, though, that we need to increase is the output that comes from those. As you can see here, Europe has less collaboration with us, but the productivity is much, much higher. This is just in a nutshell what we do as the CSR, and we're delighted to be here and to present to you what we do. Thank you.
Thank you, Dr. Sandile Malinga. I wanted to call you just by your surname, but then I remembered that there is another Dr. Malinga out there, who is not known for research. So thank you very much. And I think the second thing, I'm just going to say Dr. Sandile, because last night I'm already being encouraged to go into comedy, but I know engineers are stressed people. They want to laugh all the time. I came across a quotation which said, scientists study the world as it is, but engineers create the world that has never been. But I think with that, we might just make a special arrangement to recognize you as an engineer. We have the Engineering Council here, so we can do that. And lastly, Doc, my first bursary interview, by the way, I'm an engineer. It's hard to believe with this hair, but that's what happens when you scratch your head the most. My first bursary interview was here, came in my school uniform, a young man from Venda, have never seen any escalator, double-story building. Then you put me around, of course not you, but you put me around 6 scientists. The first question was, how much water do you think is in the Val Dam? It had to be a civil engineer. But what I'm saying is that I didn't get the bursary, but I'm saying that I'm available. As we move along, we are going to have some remarks from Professor Elizabeth Taylor from the International Engineering Alliance. A round of applause for Professor Taylor.
I need to get my presentation. Can somebody assist me to make it the entire screen? Thank you very much. Honourable Minister Ramagopa, Her Excellency Engineer Saleko, and all protocols observed at that point, because I am sure I will tongue twist every name that I come across. I am honoured to be here today, and this is my first visit to Africa, and it is long overdue. So thank you very much for the invitation, and I look forward to sharing with you some thoughts about promoting mobility and inclusiveness in the International Engineering Alliance. And I'd just like to say at this point that the Engineering Alliance is owned by everyone. It's not a thing out there, but as TC, who is on the governing group, understands more than perhaps anyone else here, we are the servants of our members and of what we are trying to achieve in terms of accreditation and registration of engineers to increase quality and to increase mobility. So the first thing, and I'm not going to answer this question, is to ask some questions, of course, as we should. Why are they important? And why are they important for Africa? And what type of mobility or inclusiveness is relevant and appropriate? So rather than answering them, I'd like to use that as the frame within which I then move forward. Engineering mobility, I think everybody can understand that from a purely business point of view, has been something that's very important to engineers, as increasingly a lot of the transnational engineering organisations have sought to ensure that they can have this business, for example, operating 24/7, or that they can access sort of engineers from around the world. That has led over the last few years with a number of different models on how that might be achieved, of which the International Engineering Alliance is one. There are others. There's the ABET model, the ECUK, the Engineering Licensee Arrangement within the UK. There is the European Network, and there is the Federation of Engineering Institutions of Asia and Pacific. And each has set up to work through what it needs for its needs, including the International Engineering Alliance. So what are we? We are a global not-for-profit organisation comprising members from 41 jurisdictions within 30 countries. There are 7 international agreements related to the accreditation of engineering programs, and then registration and chartered processes at the professional technologist and technician membership profiles within the engineering team, because all of those profiles are equally important as we move forward with the development of each of our economies. So they do govern the multilateral recognition of engineering educational qualifications. The term there that is really important is multilateral. It means that when an agreement is reached between, say, 23 countries, as the Washington Accord has, then all 23 of those jurisdictions accept the education within each of those countries. It saves a lot of paperwork around bilateral agreements if we can work through on that multilateral arrangement. And at the moment it covers over 60% of the world's population, but we'd like to see more. So the framework within which we are operating within the International Engineering Alliance at the moment is to work out how we can work through the UN Sustainable Development Goals. We certainly don't use those formally within the development of our artefacts because, of course, things change over time. But at the moment, they are a very good framework within which we can operate. It gives us language to think about how we in engineering can deal with the issues that are facing our communities, both for the future and as a result of engineering. So in that sense, engineering has a large role to play. The other part of that mobility is inclusiveness. It's all very well to have mobility, but if it is done in a way that is imposing one way of doing things rather than being inclusive of many ways of thinking about a situation, it is all the poorer for it. So inclusiveness must be the value set within which we consider how we move forward with mobility. Because harnessing diversity and collaboration will enrich us all. There is a lot of evidence that whenever a system is captured by one culture, by one worldview or one intellectual tradition and iterates to one metric of success, its capacity for intellectual flexibility and agility is significantly reduced. And I'd have to say that the last couple of 100 years have probably made that point even more pertinent. So active engagement by all is what enriches us, what gives us rich outcomes, and which enables us to pivot and be flexible in the very fractured, changing environment in which we operate. So that point about the last couple of 100 years is that engineering practice has assumed in the past the superiority of man. It has assumed that it is the art and science of directing the great sources of power in nature for the use and convenience of man. And certainly when I was doing my engineering, that was the subtext of the way in which we operated, that the world was an infinite resource for us to draw upon, that it would be there forever with us. As one of the items that I was told as a young engineer, that we were the priests of material development, or the work which enables men to enjoy the fruits of the great sources of power in nature and the power of mind over matter. That we were going to put aside all those societal norms and rise to a stratosphere that would leave humanity behind, and we would operate on an objective level that made no allowance for culture, for diversity, for different understandings and different relationships that we might have with our communities and with the earth within which we rely. So if we are going to be engineers for the future, it is very important that we own our past. We did engineer the present, and there are magnificent outcomes that have come from that. But we did it at great cost, particularly to some parts of the world and to our environment. And so the challenges that we as engineers have now is that we are going to have to deal with the engineered presence that we have left, that we have with us, and make something from that that will be sustainable into the future. I often ask that question, can we actually grasp that we are expendable, that we are not some pinnacle, and that perhaps engineers might be the tools of our extinction, that perhaps it is time for us to also have humility in terms of our relationship with how we move forward with our work. So back to what this framework means for the International Engineering Alliance for inclusiveness, as well as the mobility and quality expectations that we are driving around engineering, is we are promoting mobility and exclusively through 4 levers: our membership, our benchmark standards, how we do accreditation, and the relationships that we have developed. Our membership in 2023 is diverse. I would just like to point out that at the moment, one voice that is very absent is that of the richness of diversity of the African nations. That South Africa and Nigeria are, at this point, the only 2 members of the International Alliance. There is very strong representation through Asia. There is very strong representation increasingly in South America. But we welcome and we look forward to working further with the very strong support that we have had through EXA to drive an agenda to increase the voice of Africa into the International Engineering Alliance, because we are about how we capture all our voices moving forward. We work collaboratively. It is the basis of everything we do. We develop strategies collaboratively. We do peer review of each other's processes and systems for accreditation and registration, not because there is one right answer, but because we need to develop collaboratively what quality we all believe we would be comfortable giving mutual recognition to, and then working out how the customised or the appropriate processes for each of our members can be looked at and considered as equivalent across our system. So, for example, the way we do things in Australia will not be the way that we do things in EXA in South Africa. But we have worked through how that recognition of mutual recognition of equivalency is a metric that we can use to both capture richness, but at the same time not iterate down to one worldview, to keep the flexibility of that intellectual openness to drive us forward. It is hard work. It requires constant maintenance. It's easy to slip into actions derived from unintended subtle claims about our way's superiority, certainly to misunderstand across our language nuances in our haste to make things happen, and engineers are very keen to make things happen, and to deploy shortcut metrics. This is my favourite. I do this often. I'm setting up metrics all the time and then realise I've left half the voices that should be in it off the table. And again, it's the active engagement by all that results in rich outcomes. So a lot of what drives us then is the collective understanding that we draw from all of our stakeholders. One significant player in the past, he is still with us, but perhaps getting to an age where he doesn't come to as many conferences, has been Dato' Lee in Malaysia, and his very, very insightful understanding of perhaps what the relationship is between industrial revolutions and economic growth for the majority world, and how we can ensure that we think about how we move forward with a different lens on what development means and what its outcomes will be for our communities. I have learned so much from a number of visits to Bangladesh about the way they have managed that nuanced relationship between development and making sure that the needs of the present do not close off opportunities for fit for future purpose technology pathways. And this is always the difficulty, how to do development with international mindset that has been set up on that resources and man relationship, and yet not be held captive by the expectations of perhaps a world of colonialism that does not give options for, or the same options for everyone in moving forward. We have taken these ideas into the way we have developed the graduate attributes and professional competency standards. It was reviewed a couple of years ago through a WUFIO IEA working group led by Professor Bülent Özoğlu from Mudik in Turkey, and every engineering organisation around the world, from within the WUFIO, the IEA membership base and beyond, on what should be the graduate attributes and competency standards that we as the world, the global community, were prepared to live with. It doesn't mean that every one of our members has to have that wording, but they have had to do an analysis to show that the wording they use is equivalent. So Australia, for example, doesn't use those words, but because we already had competency standards and we love what we developed years ago, but we'll probably move to this moving forward. Again, that openness to allow for a nation, for a jurisdiction to ensure that its voice is part of how it lives within the IEA. And all signatories and members now have agreed that they will have a roadmap to implementation in 2024. Not implementation by 2024, because again, the pathway for implementation is going to be different for each of our members. They have also been translated into French, Spanish, Arabic, Russian and Chinese, and there's no reason in the future why there can't be more. The Spanish edition, for example, was very interesting. It was translated in China, but then Mexico, Chile, Costa Rica, and I'm just going to forget one here, Peru, joined together and did a working party to go through it and see whether their Spanish related to the Spanish that had been translated into. A few words were changed just to get the nuance of what their way of speaking and understanding were, so that they were comfortable using that document to support their development within their communities. We're very conscious then credentialising and accreditation and building engineering capacity within that idea of moving forward will require a metamorphosis in engineering thinking, transformed engineering practice and innovative educational models. And we are working hard on that. The metamorphosis in engineering thinking is very much about understanding that we live in a world of change and uncertainty, that we need as engineers to take individual responsibility. We need to be open to different voices. When I was doing engineering, there was a little elective on the side called environmental engineering that no real engineer would do, because it was all about, for example, the impact of deforestation on rivers. And of course, no real engineer would be interested in that sort of thing. So we have moved forward, but we need to keep that openness to understand that the voices that perhaps that we don't want to listen to are the ones that perhaps we need to at least consider. We need to understand how we can visualise other futures and think differently. And having just been in the Women in Engineering forum, that is very much part of it, that the voices of women and other minority, other ways of thinking need to be part of who we are. Because if we are going to take responsibility, if we are going to move forward, we don't need to just be talking about the technologies of the past, but the ones that are coming forward. So when we talk about quantum computing, are we as engineering yet talking about what legacy of waste we are leaving? Or we are so captured by the shiny toy that we haven't learned the lessons of the past. We haven't embedded the expectation that the waste will be part of the answer or part of what we will need to deal with. That when we build a new freeway, that we do have to ensure that it is maintained if it is not going to be a legacy problem for future generations. We need to transform our practice to think of all sorts of different models, and there are many models that we can use to ensure that our future is not a repeat of the past. Our agreements are doing this at the level of professional engineers, and we are doing the same thing in our educational models, because the system of accreditation relies on universities that have embraced the future as well. And we have chosen outcomes-based education as the basis for thinking about how we have rigorous curriculum design that can certify that the graduates have reached the competency or the graduate attribute standards by having a model that allows universities to do it whichever way they would like to structure their curriculum. Without, when I was a dean and looking after nursing, it was that they would come and count how many sheets we had next to the beds. It's not that sort of curriculum imperative. It's about being creative, being innovative, but also having the evidence to show that the outcomes have been achieved. Australia, I was telling someone the other day, happened to have an aeronautical engineer who used a verification model. That's not going to be appropriate for everyone, but we can share stories of how to use these ideas. We also work with relationships. We have a fantastic relationship with UNESCO and WFIO also, and I just mentioned the review of the graduate attributes, which was done in collaboration with WFIO. We are working at the moment with NA in a publication of best practice, and we have always had very good relationships with FIAP. We have worked collaboratively with them. We often have different ideas on pathways, but that's the richness of how we all improve, because we do have those different understandings coming forward. So in conclusion, the peace and prosperity continues to be fragile for all of us, but especially for those whose lands lie in the confluence of history and resources, geopolitical manoeuvrings having a significant impact on opportunities to create a better future. From our perspective in the IEA, there's no easy or singular path to address this, but one powerful tool we have is to share our stories, to work together, to be open to our differences and how we can learn from those to create a better future for all. So from the Engineering Alliance, that is what drives us. And I hope you've learnt a bit more about us today. Thank you.
Thank you, Professor Taylor. I think what really stood out for me is that we need to keep the openness and not just be captured by the shiny toys. We need to remember that engineering is about solving problems, and the problems that we've created, we have to solve them as well. Prof. Taylor, I saw you talked about Sydney. Are you from Australia? I think just tell Eddie Jones, your rugby coach, after that match, that we do have a soccer team this side who can also give them comfort and counsel. How to stay encouraged when you're down. But thank you for that insight, Prof. Taylor. I think maybe just some announcements. I think the first one is there is a CPD accreditation process that is happening for this event. So you're not just coming here to have the lovely lunch and have the lovely conversations. It's about how do we develop ourselves within our profession. So at the access stand, there is some codes that you can get. There's a different code for each day. So please make your way there. The second announcement that I would like to make is at this year's conference, there is a business matchmaking. Right? So I think Prof. or Dr. Malinga there talked about there is not enough collaboration going on. So please make sure that we collaborate and we ensure that we are leveraging those partnerships that even Professor Taylor alluded to. Next up, we have a very insightful, a very interesting lady. Minister Ramohopa, I think I was too excited about you earlier on. So the next speaker is also in politics as well, and she's an engineer. I think a round of applause for that. As you can see, we're giving you brave speakers, the engineers who face on those politicians and talk about those big words that we often have to take the dictionary for. I do remember seeing another video, I think it was a politician in Nigeria who was talking about krinkum krankum. I don't know if you remember that. But this engineer is going to come to a level. She couldn't do that, but she's not going to do that today. Engineer Oyedele Salako, please come up to the stage. A round of applause for our Honorable Minister.
Hello, how are you? Thank you very much. Nope, I'm just going to read. Thank you. Good morning, ladies and gentlemen. I would like to adopt the already well-established protocol, but permit me to recognize the Minister for Electricity, Dr. Ramokopa, who is here today to share this occasion. Yesterday, ladies and gentlemen, I had the honor and privilege to deliver the keynote address at the African Women in Engineering Forum, organized as part of this 7th Africa Engineering Conference. And I thank the conference organizers for giving me the opportunity to represent my paper before the full house today. I'm truly awed by the eminent men and women engineers from across the continent who are gathered here, and believe that you will all join voices with ours as we work towards improving the levels of participation and experiences of African women in engineering. One of the best decisions I made in my life was to study civil engineering. Yes, I was good at STEM subjects, and I had a whole range of options available to me. I could have studied medicine. My father was a medical doctor. I could have studied architecture or any of the natural sciences, but I decided to study civil engineering. I had role models like my uncle, Engineer Mojid Salako, and a family friend, Engineer Mrs. Tower Williams, who guided me, and I thought, yes, why not? And I haven't regretted it. Being an engineer has opened a wide vista for me. In addition to being a civil engineer, I've had other careers. I've been an entrepreneur, and I've been in management. But at the end of the day, it is the engineering in me that has been my launch pad and made it easy for me to adapt. Today, I'm a politician, an elected public officer, and I can tell you that my engineering skills are still as useful and relevant as ever. I often get asked how I adapted so easily to becoming a politician, and I answer, I'm an engineer, we're versatile. In this paper, I'll discuss the participation of African women in the engineering sector and their impact from an economic, environmental, social, and governance perspective. I'll discuss the challenges faced by African women in engineering, while also celebrating their remarkable accomplishments and exploring the potential for growth. The challenges, which include gender biases, unequal pay, unfair workplace practices, are not unique to engineering and to Africa, but we'll agree that they may be more prevalent in engineering and in Africa due to the perceived masculinity of the profession and cultural norms. According to the United Nations Sustainable Development Goals, Goal 5, gender equality is not only a fundamental human right, but also a necessary foundation for a peaceful, prosperous, and sustainable world. One of the targets of SDG 5, which speaks on achieving gender equality and empowering all women and girls, is to ensure women's full and effective participation and equal opportunities for leadership at all levels of decision-making in political, economic, and public life. However, in its SDG report for 2023, released just last week, the United Nations states that the world is not on track to hit its SDG 5 target to achieve gender equality by 2030. It concludes that at the current rate, it will take 140 years to achieve equal representation in leadership in the workplace. This is disappointing, but not surprising. Even though women have come a long way in the almost 150 years since 1876, when Elizabeth Bragg was awarded a bachelor's degree in civil engineering by the University of California, Berkeley, and she became the first female engineer in the United States, women still account for less than 20% of engineers worldwide. The number of women engineers in Africa hovers around 10%, even though women make up over 50% of the population and form majority of the workforce in most countries. The percentage reduces further in leadership positions. In South Africa, for example, a study conducted by the Engineering Council of South Africa revealed that women make up only 12% of registered professional engineers, indicating a significant gender gap, while only about 4,500 of the 60,000 registered engineers in Nigeria are female. That's about 7.5%. However, it is not all doom and gloom. Data from UNESCO shows that in 2018, some African countries reported the highest rates of women engineering graduates. These countries include Benin, Algeria, Tunisia, Morocco, Namibia, and South Africa. Distinguished ladies and gentlemen, this issue goes beyond just numbers and statistics. It is about empowering women to become leaders, decision makers, and innovators in this profession. We cannot ignore the fact that gender disparities persist in the engineering sector. It is disheartening to see talented women being undervalued or systematically excluded from opportunities due to biases, stereotypes, and societal expectations. Our shared goal must be to obliterate these barriers and create an environment that embraces diversity, where women can thrive and contribute their unique perspectives and skills to the engineering sector. It is about fostering an inclusive culture that recognizes and rewards excellence, regardless of gender. Women who have persisted have been able to overcome these difficulties, enabling them to find fulfilling and rewarding experiences in the engineering profession. But going forward, we must create a level playing field for men and women by encouraging mentorship programs, networking opportunities, and career guidance initiatives that inspire and pave the way for women to pursue ambitious engineering careers. Have I been a victim of biases, stereotyping, or unfair workplace practices? Certainly. What is quite interesting, though, is that sometimes biases come from the most unexpected places, sometimes from the people who love us the most. My father was my greatest cheerleader. He wanted me to excel and ensured that I got the best education. But he was still the most conservative of parents. I recall one example about 30 years ago. I was transferred from my office in the UK to Indonesia. That, of course, was in the dark ages. No mobile phones, no emails, and it was very difficult to get in touch with their loved ones around the world. My father was in despair. How could his young girl be sent across the world on her own? If he had had his way, I wouldn't have got to Jakarta. Meanwhile, I had the time of my life. It was exciting, both professionally and personally. I got to enter a nuclear plant, and I had many other unique experiences, and I wouldn't have missed a day of that experience. I was lucky that my employer at the time, Overup and Partners, didn't see me as a young lady to be wrapped in cotton wool, but saw an engineer who had the competence to represent them halfway across the world. My point here is that not all biases are malicious. They may be unconscious, but they're biases nonetheless. It's my hope that this kind of biases have reduced over the years, and that our loved ones won't hold us back, but support us and give us wings to fly. Economic considerations. Women's inclusion and empowerment within engineering have far-reaching implications in shaping a more sustainable and equitable future for our continent. Increasing women's participation in engineering can significantly boost Africa's economic growth and development. Studies have consistently shown that diversity in the workplace leads to greater productivity, innovation, and profitability. By unlocking the full potential of women engineers, we can drive entrepreneurship, attract investment, and diversify our economies in a more inclusive and sustainable manner. To foster women's participation in the engineering sector, it is crucial to break down the barriers that inhibit our progress. These include addressing gender-based discrimination, providing adequate workplace support, and establishing policies that promote work-life balance and equal pay. The engineering industry needs to evolve and adapt to ensure it is inclusive and supportive of all professionals, male and female. To get the best out of women engineers, we also need to challenge outdated notions and stereotypes that pigeonhole women into certain engineering roles or underestimate their abilities. African women have immense potential to contribute to all facets of engineering, whether it be consultancy, construction, manufacturing, academia, energy, or technology. We must create an environment that encourages and welcomes their participation. The social aspects of women's participation in engineering cannot be overlooked either. Engineering projects, whether they are related to infrastructure, transportation, or urban planning, have a profound impact on local communities. When women are actively involved in the decision-making process, engineering solutions become more responsive to the needs of different segments of society, promoting social equity and inclusivity. Women engineers are uniquely positioned to consider the perspectives of marginalized groups, fostering community-based development and enhancing the social outcomes of engineering projects. As we face the pressing challenges of climate change and environmental degradation, integrating women's perspectives and expertise is critical. Engineering solutions to mitigate climate change, develop renewable energy sources, and design sustainable infrastructure must be inclusive and consider the unique insights that women bring to the table. By including diverse voices in engineering projects, we can ensure that our response to environmental issues is comprehensive, effective, and sustainable. Good governance is a fundamental pillar for fostering the full participation of women in the engineering sector. Companies and organizations must commit to strong gender equality policies and practices, ensuring fair and transparent recruitment, promotion, and remuneration practices. Active measures should be taken to challenge and dismantle any discriminatory structures that hinder the advancement of women engineers. For instance, the Norwegian renewables company Scatec has been able to achieve 30% share of female engineers in its O&M team in Egypt, a country which has a low level of female participation in its overall workforce, by focusing on non-gender biased competencies such as technological capability and intellectual capacity throughout its recruitment processes. By fostering a culture of accountability and inclusiveness, we can create an environment where women can thrive and contribute fully to the engineering sector. The role of education and training cannot be overemphasized, as the dearth of females in STEM reduces the workforce available for employers to select from. Access to quality education and technical training should be provided to young girls from an early age to enable them to develop a passion for STEM. Investing in STEM education for girls would not only equip them with the necessary skills, but also instill the confidence to pursue engineering as a career path. This has prompted many governments, private organizations, and NGOs to come up with initiatives that will attract more girls to STEM subjects. For example, in 2016, Zimbabwe introduced free tuition and boarding fees for students in public schools taking advanced level science subjects, which has increased the number of girls taking science and engineering degrees. In Ogun State, Nigeria, where I serve as Deputy Governor, we have boosted girls' enrollment in our 8 technical colleges by putting in place scholarships and grants. We also encourage girls to pursue STEM subjects by introducing them to co-curricular activities like JETS clubs and other hands-on STEM activities at an early age. Examples of private sector players are the Mastercard Foundation and the Schlumberger Foundation. The Mastercard Foundation is collaborating with local partners across Africa, including the African Institute for Mathematical Sciences, to design programs that support increased participation of African girls and women in STEM education. The foundation also sponsors the Scholars Program, with over 70% of scholars being female. The Schlumberger Foundation is a nonprofit organization that supports science and technology education and provides grants for women in engineering under its flagship program, Faculty of the Future. We need to harness the possibilities made available by these collaborations in our different countries. Distinguished ladies and gentlemen, unfortunately, even after girls overcome the hurdle of education, job inflexibility makes it very challenging for women to stay in engineering. Creating support networks and communities is equally essential. Establishing platforms where women can connect, share experiences, and uplift each other is crucial for career advancement and collective growth. Mentorship programs that match experienced engineers with aspiring young talent can help bridge the knowledge and experience gaps, provide guidance, and nurture future leaders in the engineering sector. Several countries have separate professional organizations for women engineers. An example is the Association of Professional Women Engineers of Nigeria, APWEN, one of the societies of the Nigerian Society of Engineers, which was formed in 1982 by 6 women engineers who realized that they had to come together to provide support for each other and mentorship for young girls. Another example is the Women in Engineering Committee of the FAEO, which provides a forum and framework for female STEM advancement in Africa. We can also learn from other countries. The Republic of Korea realized that while more women are enrolling in engineering courses than ever before, there are still low ratios of women in high-demand sectors such as the automotive, mechanical, electrical, and electronics industries. To address these shortages and increase the retention of women in the workplace, they have introduced a policy called the 4th Basic Plan for Women Scientists and Engineers, which provides support for women throughout their career, including the provision of adequate childcare and career re-entry programs. As we continue to work towards gender equality in engineering, we must not forget the importance of advocacy and raising awareness. Bringing attention to our achievements will serve as inspiration and motivation for future generations. All of us here at this conference have excelled in our respective occupations and are role models, showcasing the limits when you choose a career in engineering. I will specifically mention a few African women from across the continent whose inspirational advocacy exemplify the enormous potential African women have to shape the engineering sector. Dr. Dorothy Okello from Uganda is a renowned electrical engineer and advocate for women's empowerment in technology. She's the co-founder of Women of Uganda Network, an organization promoting the use of information and communication technology by women. Her work has been pivotal in bridging the gender gap in ICT access and digital literacy in Uganda. In 2016, she became the first female president of the Uganda Institute of Professional Engineers. Engineer Margaret Oguntala from Nigeria is a chemical engineer who has taken up many leadership roles in the Nigerian Society of Engineers, receiving the coveted NSC Presidential Award 10 times, as well as the APWEN Innovative Leader Award. She instituted the Margaret Oguntala Capacity Development Academy, which provides mentorship and hands-on training for young female engineers. In January 2024, in about 3 to 4 months, she will shatter another glass ceiling and become the first female president of the Nigerian Society of Engineers since it was founded in 1958, yes, 65 years ago. Engineer Kellen Buchedi of Ghana is a structural engineer with a passion for project management, corporate governance, and the education and training of engineers. She advocated for the passage of the Engineering Council Act in Ghana, a law that requires the registration of all classes of engineering practitioners. She has also been active in professional engineering organizations, and in January 2021, she was sworn in as the first female president of the Federation of African Engineering Organizations. This list is by no means exhaustive, but by highlighting the contribution of these prominent female engineers and celebrating their accomplishments, we not only recognize their individual successes, but also showcase the transformative impact that women in engineering can have on society as a whole. To consolidate its efforts on mentorship and advocacy for female engineers, In 2014, the UK's Women Engineering Society dedicated the 23rd of June as International Women in Engineering Day, INWED, to honor women pursuing engineering careers, raise their profile, and highlight the amazing career opportunities available. INWED has now achieved a global reach and is being celebrated in several countries across the world, and has also acquired UNESCO patronage. We can also leverage this day in our respective countries as we endeavor to bring more girls into engineering. In conclusion, ladies and gentlemen, I stand here today with immense pride, acknowledging the remarkable achievements of African women in engineering, their relentless pursuit of excellence, their unwavering determination, and their indomitable spirit, are not only transforming the engineering landscape, but also reshaping our societies. I'm also very hopeful that by recognizing the economic potential of women engineers, incorporating their perspectives into environmental solutions, fostering social inclusivity, and ensuring good governance, the transformative power that women have will be unlocked within the engineering sector to the benefit of society as a whole. Let us honor our contributions while collectively committing to dismantling the barriers hindering women's full and equal participation, embracing diversity, and creating a better Africa for all through women's active involvement and leadership in engineering. Because as we all know, we engineers are the ones that change the world and make a difference. Together, we can create a future where African women engineers thrive, innovate, and lead. Once again, I thank the organizers of the 7th Africa Engineering Conference for giving me the opportunity to share my thoughts with you, and I wish everyone pleasant deliberations. Good morning.
Understood there. Clear as daylight. Thank you very much for giving us those insights from your paper. I think it'll probably be a good moment right now to ask all our female engineers to stand up, even the students. You know, ladies, please stay standing. That applause is okay for me for doing a good job here. Can we give them the applause which is going to signify the support that we are going to make in bringing diversity in our industry? Thank you very much. All right, we are going to move to get the address from the Minister of Electricity. He's a man that I've been given the task to introduce him. I don't know why my good mentor, Mr. Zimu there, you know, did not help me, but it's like that. He just came to me and said, "We must start on time." That's Mr. Zim there. But Minister Ramkhopa holds various academic qualifications, and Minister, we do have students in the audience. Not just the civil engineering degree that he has, but degrees in public administration, business leadership, public affairs, to name a few. While you might think that he's only been in public service, he's also been in corporate, where he's been the chief executive of various entities and has been recognized by various awards: 2008 MTN Boss of the Year, 2009 CEO of the Year, very, very impressive. His career in public service has not only been at a national level, starting right here in this city of Tshwane, where some of the things that we see today, which we enjoy, were the brainchild during his tenure. In this province, played a significant role in economic development. At national, he headed the investment and infrastructure unit in the presidency. And now, being the Minister of Electricity. For me, one of the most notable times were when listening to some of the addresses he made, seeing him on TV, listening to power station managers, standing on a chair, you know, he leveraged this political address. When you address the masses, you use whatever is next to you. Of course, it looked like it was Silas's idea, though. But something he said which was very, very fresh for me is that as we have been addressing load shedding and the lack of investment or investability of some of our organizations, is we need to look at that against the cost of what load shedding is to the economy. And I thought that was very, 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 very fresh. And with that, seeing the Ministry of Electricity created and having Minister Ramokgopa putting engineers right in the executive of the country was a very welcomed decision, at least for us as engineers. So ladies and gentlemen, please, can you rise up and welcome the Minister to the stage. Too late, Minister.
It's too late.
Thank you very much.
Thanks. Oh no, thank you very much. My team knows that I don't prefer people to stand up to receive me. I'm just an average South African who's making a contribution to resolving part of the social conflict in society. So let me start by first expressing my most sincere appreciation at the invitation extended to me by the Engineering Council of South Africa, and also to acknowledge the President and your esteemed executive of EXA. So thank you very much, Ms. Buthelezi, for the invitation. Let me also acknowledge Her Excellency Engineer Oyadele Salako. I must say that you presented one of the most compelling papers that begins to surface the gender dimensions in the discipline of engineering. I really didn't see it that way until after you had shared it with us. I think it's one of the most compelling articulation of what it takes. And of course, I'm saying I haven't seen it that way because of my own prejudices, just reinforcing the message you're making in your paper, that we have no full appreciation of what women have to go through to be in the discipline of engineering. I mean, when I was in my class, the final year, I think we had only one female student, and the class before there was no female student. And in the class immediately after us, I remember only seeing two or so. In our class, I think the final year we were about 9 or so. So I think just listening to you, I think it brings to life some of the most lived experiences of females that they have to go through in relation to the discipline of engineering. And in fact, this helps me to also better understand the fact that at ESCOM we've got 14 coal-fired power stations and 1 nuclear power stations and a number of about 3 picking stations. And there's only 2 female general managers. I think it brings it home. So I'll have some degree of sympathy and just an appreciation of what they have to go through. Thank you very much for that. And I hope that the paper, by definition, is public, and you can allow us to use it. I'm going to cite you in some of the public statements I'll be making. I'm sure permission is granted. I will not plagiarize. I will not plagiarize. And thank you very much also to Prof. Elizabeth Taylor for being present here, but also taking us through a journey of the International Engineering Alliance. And just to thank Dr. Sandile Malinga, who's our host here. I must say that there's some degree of familiarity here because of two reasons. The first one is I'm in the company of engineers, fellow engineers. The last time I had such an honor was when I was at university. So it feels great to be here because every time you have to respond to a number of issues that are in the public discourse, and you can imagine that we are at the coalface of that public discourse because of the nature of the problem that is confronting us. And also when I do, if you like, media interviews. I go to a number of platforms trying to explain the nature of the problem and how we resolve the problem in a typical engineer's fashion, just surfacing what the numbers are. I get to learn that I lose a lot of the audience, and some of the news anchors, they say, no, but put it in simple speak. I can do that in simple speak, but first you must understand the nature of the problem statement. So you must articulate the problem statement and then fashion responses to respond to that fashion statement. And by definition, you have to quote a lot of numbers and also do some computation and illustration of what it will take for us to resolve the problem. And you find that I have to explain myself again and again. When I'm in the company of engineers, so it's very easy today for me to articulate what I'll be sharing. And then the second reason why I feel at home here is because on the account of what Dr. Malinga has shared with us, the CSIR is one of the marquee research institutions, not just in the country or on the continent, but globally. So it's a citadel of intellectual discourse and also a platform for discovery. As he has shared with us, they are doing tremendous amount of work to help South Africa to resolve its challenges, to modernize, to innovate, but also creating a broad platform or expanding the flow of opportunities for young people who are invested or aspiring to be scientists going into the future. So CSIR is indispensable to the resolution of the social conflict. When I say social conflict, I mean the nature of the challenges that are confronting us, but simultaneously the opportunities that presents going into the future. So when I say social conflict, I really mean that. So thank you very much, Dr. Malinga, for sharing with us the work that the CSIR is doing, and also sharing with our fellow compatriots and those from other parts of the continent and the world the work that we are doing. I'm going to be sharing with you, if you like, the issues around the energy infrastructure on the continent. So I take a more Pan-African view, on the nature of the topic. So, and then at the end, I'll try and localize it. And by localizing, I mean I'm going to domesticate the nature of the problem so that I get to surface the magnitude of the challenges that are facing the South African economy as a result of perennial underinvestment and policy missteps over a passage of time. And that has plunged the country into darkness, literally plunged the country into darkness. I'm making that point so that those of us, of you from the other parts of the continent, you must learn and unlearn from our experiences. So I think it will be important that you don't follow the path that we're following in relation to the policy missteps and the kind of investment choices that we have made. I think being you can benefit from last mover advantage. So it's important that you learn from the mistakes of others so that you don't get to repeat them. Having said that, I think there are significant opportunities on the continent which are not fully explored, and I'm going to share those with you, and how infrastructure can play an important role in the resolution of that question. And by infrastructure, when I say infrastructure, by definition, engineers will be central to the resolution of the problems that are facing us, like we do in many other encounters. I don't know. Where do I point it? Oh, okay. So those are the contours of the presentation. I think it will be important that at the onset I position the presentation by invoking, if you like, the provisions of the Agenda 2063, which is a comprehensive articulation by the leaders on the continent of an Africa that we want, and Africa that we desire. Essentially, some of what gets to be articulated and codified in Agenda 2063 are aspirational targets, but a lot of them are targets that can be achieved. And for obvious reasons, I'll just focus on the dimensions that speaks on the infrastructure issues and opportunities, and that which we aim to achieve as a continent. And then there are structural, if you like, challenges that requires our collective attention. So some of them are structural, some of them are systemic, and I'll make that distinction when I get to that point, that requires our collective attention. And as a result of those structural weaknesses, Africa is not in a position to realize her potential. And I think that it's a challenge that gets to be thrown to all of us as practitioners in the space to make sure that Africa is able to ascend. I mean, we've got a significant amount of endowments in the form of renewable energy sources, the platinum groups of metals. You mentioned them, the amount of real estate that we have on the continent, but I think we have not been able to fully exploit that. And I'll say one or two things about some of those challenges. Of course, some of them are objective and some of them are subjective. Objective because they are supported by facts. Subjective, some of them, because it's my own personal interpretation or take on the nature of the problem. So you might arrive at a different conclusion. Having used the same set of facts, we might see the problem differently. But I think what will not be in dispute is the facts that will be surfacing. So those are the objective consideration. And then you and I can have an intellectual debate around what that means and what the conclusions are I arrive at. That's subjective, I must say. And then the importance of energy infrastructure in driving growth. The point there really I'm trying to make is what in political science is referred to as a political economy of energy. So there's a correlation between the amount of universal penetration, the rate of growth of energy resources, the degree to which you are able to exploit them, and also economic growth in its multiple dimensions. So I'm not only looking at just gross domestic product, I'm looking also at the issues of human development, universal penetration, the quest for the attainment of an egalitarian society for others, or an equitable society, so that everyone gets to benefit from the dividends of the resources that we are having. So I'm just saying there's a correlation there. So I'll try and strike that correlation. You might arrive at a different conclusion yourself, but the point I'm making is that without the full exploitation of this resource, we are unlikely going to achieve the kind of growth that we desire. What is that complexion of growth is a function of our ideological orientation or socialization. So that's, again, a subjective point. I leave the subjective issues out so that there's consensus more on the objective issues. And then there are issues around the regional energy supply integration. So what's the point I'm making there? Is that if you look at the configuration of the energy infrastructure, electricity infrastructure, in the region of SADC. It was heavily reliant on surplus energy and cheap energy that was available from South Africa. And as a result of our challenges, like I said, they are historical, and I'll say one or two things about some of the policy missteps that we have made. Then there's energy hunger in the region. So other jurisdictions, sovereign countries that are connected to South Africa through the SADC, South African power pool, had relied heavily on South Africa. So they did not develop, if you like, energy sovereignty, because there was cheap energy that was available from a neighboring country, and then there was infrastructure that can evacuate the electrons. And as a result of our challenges, then they're experiencing challenges. So if you like, there are collateral damage in the general scheme of things. And inversely, the argument can be made is that if there was an attempt by our neighbors to also develop energy sovereignty, so when we are experiencing the kind of challenge that we are experiencing in the country, we could be importing that excess energy that they are generating. And therefore, we shouldn't be sitting on the kind of problem that we are sitting on. So essentially, the region is not energy secure. That's the point I'm making. And I'm advocating for us to systematically undermine sovereign borders. So if you like, your administrative and political boundaries, they are particularly unhelpful in resolving this complex question of the energy calculus in the region. So I'm making it's a political statement really, is that in the resolution of this, you must undermine, if you like, sovereign borders. And you are going to see when I surface the map of what are some of the potential energy sources, or if you like, fuel sources, that we can benefit immensely as a region and the continent by ensuring that we develop a network of connectivity. And in that way, we are going to experience energy balance. And if there's a challenge that is located in a particular jurisdiction, does not necessarily have a net negative impact on the region as a whole or the continent as a whole. So I guess that we must start thinking through those dimensions. So the lens of thinking and the resolution of the problem must not be with regards to what are our sovereign ambitions, but essentially what is a regional perspective. So it's got particular political consequence, what I'm saying. But of course, the most immediate problem is to have the lights on, is to make sure that there's universal access, we improve the levels of penetration. So you can argue that some of the things I'm really articulating, they are necessarily aspirational. We'll never get to that point. I argue differently, but I guess this is not the platform to make that point. Oh, I'm going back. And then, so this is just the 6 areas that are articulated in the infrastructure interventions that will underpin Africa 2063. And I think it's important to say that a lot of these dimensions are exceptionally different from what Europe or the major industrialized countries of the North will say as their priority, because we are still grappling with the issue of energy access. Some levels of penetration on the continent are less than 30%. So when you have a conversation about greening, decarbonization, it must be nuanced to our own conditions, because when you have these conversations with my peers, they really don't understand what you are talking about, because there's still 70% of their populations that are not connected. And you are coming here, you have the luxury of 93% of energy connectivity penetration. Leave the fact that at certain parts of the day, that energy is not available. So that's what we call load shedding. So I'm talking about the bigger conversation about the connectivity and access, because access talks to its availability and affordability, because the technology must not place an extraordinary amount of burden on the end consumer, because we are going to have energy hunger. So the electrons are available in excess, but the poor can't access them. And it's a function of the kind of technology choices that we will be making. And then there's a lot of investments that will be required. So a lot of the sovereign balance sheet will not be able to carry the amount of investments that are required. And we know that there's a big pool of private sector liquidity. So you must find creative ways of tapping into that private sector liquidity without undermining the strategic value of these assets. So my view is that you should not privatize the grid. You can find creative ways of ensuring that there's private sector participation, but the grid is still the responsibility of the state, and also the system operator is responsible for the management of the grid. But you need to resolve the issues of investment, and I'll show you as I conclude at the end that the amount of investments that are required for us to be able to accommodate new sources of generation, principally renewable energy sources, are such that we require anything upwards of about $115 billion US for us to be able to strengthen the grid and expand the lines. If you don't do that, you are not going to get to benefit from renewable energy sources because of the configuration of the grid. I'll show you what the nature of that configuration, and remember that is a function of your fuel source. So we're going after the fuel source, which is principally coal, and the power stations are constructed at the mouth of the power station, and the concentration, the density of the grid is there. The load is in that proximity. 72% of our load is here going to the north. That's where you have a significant amount of deposits of the fuel source that is coal, and then to the south, the Western Cape, Eastern Cape. That's where you have the best quality of the sun. So if you had to do an atlas of irradiation atlas located in the Northern Cape, the wind atlas, the Western and Eastern Cape, but that's areas where you don't have grid capacity because of legacy issues around where this is located. So investment will be key. Regional integration, I'll say one or two things about them. Renewable energy is important. Of course, we are committed to the decarbonization, we are in doubt, but remember that renewable energies, they survive on the redundancy of base load. So coal, gas, nuclear, hydro are going to be part of the energy mix going into the future. So I'm just saying the success of renewable energy is undergirded by the presence of, if you like, base load. So you're not about to abandon or relinquish that resource. It's about making sure that there's an optimal mix. You are able to achieve some degree of, in inverted commas, equilibrium. So it's not a binary conversation. It's not the one against the other, but it's doing both in a balanced way. And then issues of energy efficiency and inclusivity. Again, there are gender dimensions to access to energy, access to basic services. I mean, if you go to the rural hinterland, it's the girl child that must wake up very early in the morning, go and fetch the water from the nearest stream, and then bring it back home. Much later after school, when the boy child does the homework, she must cook and prepare. So that's the gender dimensions that requires attention. It doesn't lend itself clinically on the electricity side, but I think on the water side, I think you can see those manifestations that they must be assaulted and defeated, and I think that engineers possess the capacity to help us to resolve that challenge. And then on the issues of systemic challenges, there are issues around the fact that the continent constituted about 10% of global demand growth, the period 2010 to 2019, and 8% of oil growth. And that statistic is also important in the context of the conversation around cleaner forms of energy generation. I mean, you know that at COP21, one of the biggest conversations there was around the responsibilities of the global north. I think Africa accounts for 4% of the total global emissions level, and that's why there was a conversation about the equal but differentiated responsibilities. Just an admission that we are not, as a continent, responsible for the kind of challenges that we are seeing from a climate change perspective, but what we know is that the poor, downtrodden, marginalized are the ones that are disproportionately affected by climate change. So I think it's important that we have that conversation, and it's playing itself out here. So we really need to illustrate our commitment to the resolution of this problem. And of course, South Africa is a significant part of that 4% of the kind of emissions that we're seeing on the continent, because of it is the most industrialized of all the countries here. And then there's issues around the reliability of energy supply. I think it is important, especially on for purposes of production, automation. When I sit with some of the original equipment manufacturers in the country, you know that there are 6 of these OEMs on the auto sector that are producing from here. They tell you that it's not just the availability of electricity, but it's the quality of that electricity. When you have dips, the robots, they are going to lose memory, and then you must restart them. And then there's a lot of wastage. So I think it's important that we're able to resolve that question. I spoke about issues of access and affordability. So the choices of technology solutions are going to have significant impact on the ability of the poor and those that are excluded to be able to afford this electricity. So they can be connected to the grid, but it's a different conversation for them to be able to afford. If, for an example, we ban diesel for us to be able to produce electricity, that must be accounted for in the tariff structure, and diesel is the most expensive form of fuel source, and therefore the poor will be excluded from that. And then there are issues of our natural endowments, and this in the context of the decarbonization agenda. Earlier on, I think Dr. Malinga was referring to the green hydrogen as a new frontier of growth. So if you like, green hydrogen, by definition, of course, we have an industry here. We've got technology solutions. Sasol has got a technology called Fischer-Tropsch technology. Already you have a gray hydrogen, but the issue here is about green hydrogen. It's a fuel source that helps you to achieve that dismembering of the compound using the process of electrolysis. So it's important that we are able to exploit these resources. Like I said, the best irradiation level, the best wind speeds are found here on the continent and in this country. So it's important that we are able to domesticate, if you like, value addition. We know that the industrial north, about 60 countries globally that have committed to a net zero path. Some of the most industrialized countries account for over 70% of the emissions, and therefore they are prepared to pay a premium for them to access this green hydrogen. If you know, the cost curve is still steep. It's prohibitive for us, but for the industrialized countries, because their own emission to decarbonize and decarbonize faster, they are prepared to pay a premium. So I guess that in some instances, your market really will be driven by the international market. And for us as a country, because of the large-scale amount of industrialization, industrial uses, the production of, in the heavy industry, you can still deploy green hydrogen, and also the potential of the introduction of carbon borders is likely going to ensure that there's an early uptake of this green hydrogen, even given their cost premium, so that these industries are able to continue to access those lucrative markets. And then there are issues of poor infrastructure that is inhibiting growth. So if you like, the foundational network industries of water, energy, transportation, internet connectivity are key for growth. And this is an area where Africa is lacking, and it requires our collective attention. And then the point I'm making here is that the relationship, I mean, that political economy conversation I referred to earlier, makes the point that if you don't have sufficiently developed transmission infrastructure, we are unlikely going to be able to connect these renewable energies on stream. And that's why it's important at the technical level, there are solutions that the engineers can design, modernization of that infrastructure, the distribution infrastructure, but financing is a key part of that. And you can see that the electricity use per capita, there's a direct correlation. Greater use of electricity, the more the affluent people are. So I think it's important that we undermine that trend so that we are able to introduce some degree of equity in how we are able to access these opportunities. And I made the point about the need for us to attract both domestic and international liquidities in the design of the financing instruments that we are likely going to find, if you like, a sweet spot, so that you don't place additional burden on the end consumer. The state continue to own the grid. You are developing a distributed infrastructure. The system operator still has visibility about what is happening across the entire network and is able to balance the grid and protect it from grid collapse. So these are issues that requires attention, I want to argue, going into the future. And then I've spoken about the issues of access, the fact that, sub-Saharan Africa, we can see that there's high connection charges, which leads to low access because the majority of the people are not as affluent, and as a result, they can't afford that the connections, the charges that are associated with the connections. Some of them are prohibitive, exorbitant. So it's important that we are able to solve for that problem. And likely it's going to be found in the engineering solutions, and then it manifests itself on the financing side. What is the point I'm making is that you hold key, I think, as a cadre of engineers on the continent, and of course learning from our friends from outside the continent, that we find solutions to some of these problems that are confronting us, so that we are able to resolve the problem going into the future. This for me is one of the most telling slides. So you can see that there is still a significant proportion of the population that is still not connected to the grid. Of course, a big part of the grid is to support the industry, but you are going to find that local communities, even those that are within the vicinity of the industry, they are still experiencing energy hunger. So it's important that we are able to solve for this problem. As we provide, if you like, the electricity that is required to power industrial growth, ensure that the skilling, reskilling of people to participate in the new economy, to ensure that we broaden the manufacturing and industrial base, and therefore get people into productive employment. It's important that we are able to power the households going into the future. And you can see that there's still a significant amount of people who still don't have access to electricity, over 500 million on the continent. That's significant by any measure. And our ability to be able to achieve the kind of human development using the multiple indices are undermined by the fact that people don't have access to electricity. I mean, what you and I consider to be trivial, access to the internet, Wi-Fi, and the likes, these things are not possible as long as electricity is not accessible or is not affordable. And that's why we need to solve for some of the key policy issues. And what are those issues? So the issues around the policy is around to what extent the degree to which you are able to liberalize on the generation side to get additional players to help the state with the complexity of the energy mix. So in our country, we have liberalized the generation side. So Eskom is ceased to be a monopoly. It's a dominant market player still, but over time, I think that position will be diluted. Essentially, you are introducing new players into that space. But you need to be careful not to suffer the challenges that some of the industrialized countries have experienced in relation to the cost of electricity when you begin to privatize and privatize more. And the intention then is not driven by, if you like, a motive of ensuring that there's first a universal penetration, second is affordable, is reliable, but really is driven by a commercial motive for private sector trying to maximize, extracting as much as they can. So it's just a balancing equation that requires attention. And I've spoken about the issues of financing, the issues of transmission infrastructure, and the fact that it must enable the introduction of renewables, because, like I said, notwithstanding the fact that we are 4% of emissions, I think we've got the obligation to posterity, to the environment. So as we exploit our endowments, it's important that we also admit to our responsibilities going into the future. And of course, the conversation at the multilateral level must resolve the issues of financing so that it allows us to transition. As we add more people onto the grid, we are transitioning at the same time. So the point I'm making is that we can do both going forward. And then there are issues on the transmission side. Of course, we are getting to a stage of a distributed grid. So if you like, many of the grids across the continent, or let me say in South Africa, is a single point of failure, is a single integrated, contiguous, if you like, network. It's important that with the introduction of renewables, we are going to introduce a distributed grid. And then that's going to present its own challenges. First is that the system operator, someone who protects the integrity of the grid from grid collapse, must have visibility. So it's important that the projects must be able to announce themselves. And then there are issues of congestions and intermittency, because renewables are variable form of energy. So they come as they wish. When the sun is up, when the wind is there, then they come on stream. But the technical configuration of the transmission is not meant to accommodate such level of intermittency. It wants flexibility that the system operator must have control. And I guess that's an opportunity for us engineers to resolve that problem. We are born to resolve problems. You know, I was saying to someone, my wife, they say, yo, you are taking the most difficult job in the country, an unenviable task. Even others in the party, they ask me, are you normal? I say, no, I'm an engineer. We'll resolve this problem. We're not going to. We'll resolve this problem. It's a difficult problem. That's what excites us engineers. We are going to resolve this problem. And then if you are to have the same conference in the next 3 months, you'll know what I mean by we'll resolve this problem. We are there. We are getting there. Just be patient. We are resolving these problems. And then the issues around, like I said, the investment in this new asset. But really the message I'm conveying there is around technology solutions. Dr. Malinga, I'm sure there's a lot you are doing in this space. Yeah, it just doesn't sound right. You are right, Program Director. Or Dr. Malinga, I feel like Dr. Sandile Malinga, I'm sure you are helping us to read. For our visitors here, we'll share with you what the joke is. It is going to take your time for me to explain what that is. We'll explain to you what that is. But I think for me, this is two of the most exciting slides. It's just first, just an illustration of the degree of connectedness. Of course, we can have a conversation about the capacity of these lines, and there's every intention to improve the lines on the Namibian side, or improving the lines, the capacity on the Mozambican side. We think that we should be going north, essentially connecting SADC. I know the power pool on the SADC side is essentially matured. I'm told that there's a similar power pool that is taking shape on the eastern part and the western part of the continent. And I think once we pull all of that together, we're going to get to a situation where we're able to resolve or exploit the opportunities that present us. I mean, the major discoveries of gas on the west coast of the continent, Namibia, is far advanced in that there's a significant amount of deposit on the east side. This is historical. Mozambique has been doing that for some time. I spoke about the wind speed, but I think also Central Africa, the issues around the degree to which we are able to use hydro. So if you pull all of these things together, you can see that the possibilities of us greening becomes real. And I think that we are going to benefit from these opportunities and these resources if we are able to collaborate and collaborate better. And I think that the power pool on the east, west, and south, that level of cooperation will be necessary going into the future. And then we become energy secure. We undermine those political and administrative boundaries. What drives us is the quest to ensure that we industrialize on the back of these renewable resources, on the back of the demand that is coming from the major Western countries, industrialized Western countries. We'll define what those standards are as Africans. We don't need to be lectured by someone from outside. We know what is in our collective interest. And for as long as we are disjointed, we are going to be exploited, super exploited. We must determine the standards, and no one should be doing that on our behalf as an example. And then as I close, just to show you the kind of challenges that we're having. So what this map really illustrates, I should have shown you this one map, on the configuration of the grid. I did say that The fuel source is northeastern parts of the country, a province called Mpumalanga. About 12 of our coal-fired power stations are located there. There's cheap coal that is there in Mpumalanga, and some of it is low quality. The stations, the design parameters are designed to accommodate this type of coal, and that's how we've been running the South African economy. 88% of our energy resources are or demands or generation rather is coming from those coal-fired power stations. Now, with our ambition to decarbonize, the concentration of, if you like, these levels of irradiation that are of good quality. By the way, in any part of the country, be it in Mpumalanga, Northwest, or Gauteng, the quality of irradiation level is significantly better than most parts of Europe. So I'm talking about an intra-country conversation. But the best quality in the country is in the place called the Northern Cape there. But what do we know about the Northern Cape and the eastern and western coastline where you have good wind speeds is that there's no grid capacity. And you can see the amount of the opportunity cost. So the significant amount of applications by project developers. Private sector has got about 66 gigawatts of renewable energy projects at various stages of the project life cycle. The point is to connect them. We can't evacuate those electrons because of grid capacity constraints, and that's why working with Eskom, we're going to increase the transmission line by about 325%. Just to put it into context, over the past 4 years, the expansion of the line, 4,000 kilometers in the past 10 years. In the next 10 years, we want to take that to 14,000 kilometers. Now there are challenges. I spoke about the financing problem. The Eskom balance sheet won't carry that. The sovereign matrix has deteriorated, so I don't think we'll be able to carry that. We need to tap from the private sector liquidity. Then the second part is the degree of industrialization. So the point I'm making is that the kind of equipment that is required is such that we can only provide about 2 or 3% of the size of transformers that are required. And for me, I see an opportunity is that in every crisis, there's an opportunity, and you must seize that opportunity within the life of the crisis. And what is that opportunity is to industrialize on the back of this crisis, and engineers are going to be central in the resolution of those problems. We can't be importing transformers, substations from China, when in fact we've got this capacity in this country and neighboring countries. So on the back of that, you must help us to resolve that problem. So that's the point I am making, that of course will require that attention. And of course, is the transmission lines themselves, the wires themselves. Again, you don't have to be importing. As long as they see through, you know what the pipeline is. The pipeline, the certainty in relation to uptake of that pipeline, I think then you can make, it can justify upfront capital investment for you to domesticate that production. And that's why we're working with the Industrial Development Corporation, one of the DFI's, Development Finance Institution, to finance this, first the research. Of course, CSIR is at the cutting edge of that, and I'm sure there are multiple players. We need to support them and support the fact that the state will be the primary off-taker. And in that way, you are able to help to industrialize on the back of the crisis, so that when you resolve the energy problem, when the lights are finally on 24 hours of the day, there's no equivocation about whether you'll have the problem tomorrow. You have resolved the unemployment problem. You have resolved the skills problem. You are broadening the base. The coffers of the country continues to grow, and you are able to expand the social wage. The poor are taken care of. We invest in infrastructure, build roads, dams, and the likes on the back of this crisis. So there are these opportunities, and these opportunities can only be seen by engineers. And that's why we're encouraging you to help us to resolve this problem going forward. Of course, that's the point I was making. And like I say, what's the point I'm making in conclusion? The facilitation of renewable energy deployment. I've shown you the picture there. Hydro Central Africa, the gas reserves, discoveries on the coastline, both the east and west, the irradiation levels, the opportunities around green hydrogen. We're doing a green hydrogen corridor between ourselves and Namibia. We are confident about our ability to commercialize it. Of course, we are working with DSI, Department of Science and Innovation. Of course, at the center of that is CSIR, what Dr. Sandile Malinga was sharing with us. And then the issues of about attracting investments, and we must see this as tapping into that liquidity, helping the continents to realize its potential and growth, and ensure that we leave no one behind. And the issues of job creation and economic opportunities and technological advancements, that's what is going to help us to resolve these challenges. So we're looking up to you as engineers to help us to resolve this problem. Thank you very much.
Minister, thank you for that very insightful presentation. I think that the engineers in this room are up to the challenge, are more than capable, and we are ready to create those opportunities that will drive this continent forward. I'm taking away one quotation from you. And if you see it in the media somewhere, know that I had a hand in it. Are you normal? No, I'm an engineer. With that, we have come to the last item of this morning, where we will ask Dr. Mieza, CEO of the Council for Built Environment, to carry out the vote of thanks. A round of applause for Dr. Mieza.
President Buthelezi, I remember when I joined CBE, I was told that I must never miss an opportunity to tell people what CBE does. So I'm going to use that today. CBE is a big family. It's a family of 9 professional councils in the country, made up of EXA, quantity surveying, property valuers, town planners, environmental practitioners, land surveyors, architects and landscape architects. That's a family within the CBE. We have about 13 concurrent functions that we do. They range from accreditation, transformation, skills development, professionalizing the industry, identification of work. And my friend Stephen there would know that we are obsessed about transformation of the sector. And the work that we do collectively is really about driving some of the points that were made by the speakers. Let me do what I was asked to do, Chair, a program director, to thank Dr. Sandile Malinga for telling us about how epic CSIR is. I'm sure colleagues are inspired because it is a good institution. Unfortunately, program director could not get a bursary, but look at how you turn up. So it was a good thing. Prof. Taylor emphasized the importance of strategic partnership and alliances. I think what my takeaway from the speech was listening to the voices from the borderlands. Because not only us as the built environment professionals or engineers who can resolve all challenges that are facing the countries that we come from, but listening to others who are outside of the profession, it's important. And how we ensure inclusivity in the manner in which we do our work. Her Excellency Engineer Salako, I think your journey was inspiring. President Buthelezi was speaking last week at a women empowerment event that we had convened for young women in the built environment. She shared a similar experience about how she navigated in the profession that is male-dominated. And I think it's inspiring indeed to listen to your story on how you've actually succeeded to break the ceiling and be the person that you are today. And thank you very much for your story, Honorable Minister Ramokgopa, familiar face. When you mentioned Dr. Malinga, when you said, I'm feeling at home, I thought maybe you're going to start dancing. But, basically, we were deprived of that opportunity, Program Director. Maybe that's the best way of sharing the story about Dr. Malinga and the Minister, because there's a convergence there. Minister, I think one of the takeaways from the speech is the importance of practitioners to reflect in action. I think what you've done was to reflect on how we can do our work better, and also to ensure that the work that we do, we don't forget that it's about society that we serve. So it's not about bricks and mortar, it's not about electrical pylons, it's about the service that we deliver. Let me also conclude by thanking President Buthelezi, Vice President TC Madigane, EXA board members, our guests from African countries and internationally, but to you, our colleagues, for being the good audience. Thank you very much. Program Director, that's the end of my speech.
Thank you very much for that vote of thanks, and it's very important to squeeze and use this opportunity. The mic is on here, there's no button here. So we know now what the Council for the Built Environment does. President Buthelezi, you've heard and you know that the Minister is a man of many talents, which we won't go into that, but we do have a gala dinner, which maybe you must extend the invite, then we can express the other talents as well there. Ladies and gentlemen, we have come to the end of our morning session. Thank you for being energetic, for engaging, and for listening to the opportunity and the messages that we've had from our distinguished speakers. Before we go, I just want to make one correction. So the CPD points is at reception and not at the access stand. Correction was made there. And then lastly, I would just ask you to kindly allow our guests to go for a photo opportunity. Once they've left the venue, then we can go and have our break outside and carry on with the program of the day. Thank you very much, and let us enjoy the rest of the day.